Hello dear all, I hope you are ready with your pen and paper to learn organic chemistry in an easy and fun way. And to help you do that, I've got this flow chart that I've been sharing in the previous videos as well, where we did the preparation of alcohols and we did a part of the properties of alcohols. In today's video, I'm going to talk about the properties of alcohol related to the breaking of the OH bond, where the bond between the oxygen and the hydrogen breaks, under what conditions it breaks and what are the reactions where it shows this behavior, and most importantly, what supports this particular behavior of alcohols. So let's get ready. Now in this video, I'm going to first talk about the easy things. So when we talk about the breaking of the OH bond, that means we are talking about the release of this hydrogen from the alcohol molecule. So it separates from the O and moves apart. Now when we talk about the release of hydrogen ion, what does it remind of? Hydrogen atom, what does this remind us of? Yes, of course, acids which have a tendency to lose a proton H positive in a solution, in an aqueous solution. That means we are talking about the behavior of alcohols as acids. So let's see what are the general characteristics of acids. Simply put, first things, acids turn blue litmus to red. Acids react with bases to form salt and water. Acids react with active metals to form salt and release hydrogen gas. Acids react with carbonates and bicarbonates to give you brisk effervescence, and that brisk effervescence is due to carbon dioxide which is released. For example, I'll take up a few reactions that we can write in order to support our statements here. In your best interest, why don't you keep writing what we are doing? So HCl plus blue litmus turns to red. Yes, it's an acid, confirmed acid, right? HCl plus any active metal, although we do not react HCl with sodium, potassium, calcium in the laboratory. Why? Because the reaction is explosive. That's why I'm going to write the reaction with magnesium and I get MgCl2 and hydrogen gas. Acids react with bases. So let's say NaOH, very common reaction. The first reaction you study in chemistry, NaCl plus water, salt and water. Same way, acid plus carbonates and bicarbonates. So you have, let's say, the reaction with Na2CO3 giving me NaCl plus water plus brisk effervescence due to the liberation of carbon dioxide. Now out of these properties, how many are shown by alcohols? Let us see. So do alcohols turn blue litmus to red? So what I'm going to do is, let me just strike it off. No, it doesn't. Do alcohols react with bases? Yes, but they don't react with your normal weak bases. They react with only very strong bases. So for example, sodium hydride. Do they react with metals? Yes, they do react with very active metals. So for example, sodium, potassium, calcium, aluminium, magnesium. Yes, they do react with only active metals. Do alcohols react with carbonates and bicarbonates? No, sadly they do not react with carbonates and bicarbonates, telling us that they are weaker than carbonic acid. Now if you will later on when you study phenols, you will find that there are differences between alcohols and phenols around these behaviors itself. So this tells us that alcohols, yes, they are acidic in nature, but they are not strongly acidic. They are weakly acidic in nature. So let us write down equations for what we have stated just now, that alcohols are weakly acidic, even weaker than water in aqueous solution. Why am I stating the term aqueous solution over here? Because this makes a lot of difference to our explanation. We are not concerned about gaseous state at present, so we are going to concentrate only on aqueous solution. So alcohols react with active metals. Now we are talking about the release of this H. What will happen? What will be the product? CH3, CH2, ONA. Right? Now let me try and help you with the naming of this compound. Alcohol reacts with some metal here, RO negative, and there is the metal part, and H will be released. That means half a molecule of hydrogen gas is released. Now many of you ask a doubt, do we actually have half a molecule of hydrogen? No, we don't. This is just our way of balancing this equation, because you notice over here there's one hydrogen atom being replaced by the metal. So in order to balance it, we are putting it as half hydrogen. If I write the final equation, this is how I'm going to write it. So ROH plus metal gives you twice of this, because this whole equation gets multiplied by 2. So 2 ROH, 2 metal plus 2 ROM, negative, positive, plus a molecule of hydrogen gas. I hope this makes things easy. Yes, I can see some of you smiling. I used to see that very often in my classes, and it really gives the satisfaction of making the students understand something. By the way, I hope you all are writing down the reactions with me. That's why I changed the name of the channel from Learning Chemistry is Easy and Fun to Pen and Paper Chemistry, so that you are continuously reminded that you have to write down what we are learning. This is your learning, right? Okay. When I take this part, now this part of the molecule, or this part, let me keep it clear. So RO negative. This has come from the alcohol. So this is known as the alkoxide ion. Right? This is ethanol, right? That's the compound that we've got. So from ethanol, the oxide that I will get, what will be the name of this? Alkoxide. Now which alk it is? Yes, this is ethanol, right? So from there we get etho oxide, right? So go ahead and write the name of this product. CH3 CH2 ONA plus, you want to write half hydrogen, even that is correct. You want to balance the entire equation and write it as H2, even that is correct. Both are accepted. So this becomes sodium ethoxide. Remember how we used to name ionic compounds? First the metallic part and then the non-metallic part. First the basic radical, then the acidic radical. That is why sodium ethoxide. Now try writing the product for the second equation. Try it. In the meantime, what I'll do is I'll just clear this space so that we can have some more space to write our equation. So C2H5OH. gives you, yes, again, C2H5O. Okay, yes, there was not a major change. Instead of sodium, I just took potassium. You can again balance the equation and write it like this. Okay, go on to the next one. Look at the structure. 2-methyl propene 2-ol or tertiary butanol. Tertiary butyl alcohol, sorry. So plus sodium. What do you get? Again, replace the hydrogen by, yes, Na positive, right? So sodium tertiary butoxide, and again I will get hydrogen gas is liberated. Now these were the reactions with metals, right? These are the reactions with active metals. And also don't forget to take the valency of the metal into consideration. Now comes the reaction of alcohols with strong base. If I say that my ethanol CH3CH2OH reacts with NaOH, no, there is no reaction over here because it doesn't react with even strong bases like NaOH. It needs very strong base to pull out this hydrogen from the alcohol molecule. And what does it form? Yes, of course, C2H5O negative, Na positive, again sodium ethoxide and hydrogen. You know what I will try to do? I'll write it in a reverse order and let me do my favorite box over here. It's so easy to remember, correct? No. This is not the mechanism, but this is an easy way to remember. That's why that is what will make chemistry easy and fun, right? Now, how do we explain the acidic character of alcohols? And also, we are going to compare the acidic character of primary, secondary, and tertiary alcohols. Now, this is where it gets a little tricky for some students. Don't worry. First step is knowing the equations for sure. Second step is understanding, and after understanding, I will also help you to explain what are the key points that you need to list down. Yes, of course, that is from examination point of view, because at the end of the day, you need marks, right? Okay, let's go ahead. Now, before I go on to explain the acidic character of alcohols, a just quick overview of the three concepts of acid and base that we would have spoken earlier, and you must have done in class also. So the three concepts that we talk about are the Arrhenius concept, the Bronsted and Lowry concept, and the Lewis concept. So according to Arrhenius concept, acid is a substance which releases hydrogen ion or hydronium ions in solution, whereas base is a substance which releases hydroxyl ions in solution. Bronsted and Lowry concept, acids are substances which are proton donors, that means which release proton. Bases are substances which are proton acceptors, which take up a proton, right? Lewis concept is completely based on electrons. So electron acceptor is an acid, which I always remind you, A for acceptor, A for acid, and electron donors are bases, right? Why are we needing this over here? Now, in order to explain the acidic character, we see that according to the Bronsted and Lowry concept, the acid and base are interchangeable only by shifting the proton. So basically, our H positive is the ball and acid and base are playing ping pong, right? Or a TT match. So acid throws the proton and base takes the proton. So when I'm talking about acid character of a substance, first is that the acid should be capable of donating the proton or losing its proton. But at the same time, the base which is formed should be stable, should be able to catch it in order to have the game continue, right? Now here a base is being formed from the acid by simply a loss of proton. If my base becomes stable, right, so the acid loses. The base that is formed from the acid by loss of the proton would be called as the conjugate base. So that means here, according to this concept, the AB exists in pairs. Yes, the acid-base pair. For example, water. Ionization, that means it ionizes itself, H3O positive, OH negative. Water here, H2O, loses a proton, changes to OH negative. That means it is behaving as an acid. In other words, this becomes the conjugate base. Now, H2O, this one, accepts a proton and turns into an acid. Now, when it is accepting a proton, it is a base. So, this will be the conjugate acid. So, we have the conjugate acid-base pairs. Acid 1, base 2, acid 2, base 1. That's how it is. OH negative, on the other hand, why are we calling it as a base? Because this OH negative in turn can take up a proton and change to water. Right? You see the beauty of the entire thing? I'm not going to confuse you with too many things. So as I said, first of all, my acid should be capable of donating a proton. And when it will happily do that, if this base which has been formed is stable, then only it can happily lose a proton. In other words, a weak acid should have a strong base, right? And vice versa. Don't worry, we are getting there, but slowly. Now we are going to apply our acid-base concept to the alcohols. The alcohol, if it loses an H, it will form the alkoxide ion, and that all happens in the presence of a strong base or strong metal, right? Which is again a strong base over here. In other words, our alcohol is behaving as an acid and converting itself into a conjugate base here. And the base, on the other hand, is accepting a proton. So this is our base 2, this is acid 1, this is conjugate base 1, and this is conjugate acid 2. It's forming what you call as an alkoxide ion. Is it stable or not stable? There are two factors that you have to see regarding the stability of alkoxide ion. What are those two factors? In most of our textbooks, it is related to the electron donating nature of alkyl group. And in most of the textbooks, you will find that only. There's another factor that we talk about, and that is the solvation of the conjugate base, which accounts for its stability. What is that? Don't worry. Let's talk about it step by step and things will become easy. Electron donating nature of alkyl group. As I said over here, this is our alkyl group. We've got electrons on the oxygen. Plus, this alkyl group has a tendency to release electrons towards the oxygen. So, it is just like saying that you are appearing for your chemistry exam and then all of a sudden a day before, your teacher says, okay, I'm going to take your practicals as well. Chemistry practicals as well on the same day. So you're already burdened and then there is one more tension on your head, right? And you are totally stressed out. Is that a stable situation? No, it is not, right? So because of this, the stability of the, so this is already loaded and you put more load on this. So the stability of this compared to the hydroxyl ion formed when water undergoes a self-ionization, right, will be lower. That means our alcohol would be a weaker acid as compared to the water. In other words, by ionization, the conjugate base that is formed, the conjugate base formed by or formed from alcohols is weaker as compared to the conjugate base formed from water, right? With the result now, because this is weak, in other words, my acid, will it be happy to release H positive and turn to this compared to, we say compared to water, which one will be more eager to lose a proton? Tell me. Yes, of course, water will be more keen, right? Now let us compare this. Now let us compare the various types of alcohol. So I've got a 1 degree alcohol, I've got a 2 degree alcohol, consider, and a 3 degree alcohol. First case, when your chemistry teacher says, okay, I am going to take your chemistry practicals on the same day as your chemistry exam. Oh, look at this case where the chemistry teacher wants to take a practical exam and the bio teacher also wants to take. Okay. So you haven't taken biology as a subject, never mind. Let's say computers, let's say some other work. So you have two teachers saying that I'm going to take your practical exam. And look at the third case where all the three sciences, they are telling you, okay, we are going to take your practical exam on the same day as your chemistry exam. Which is the least stable out of this? Yes, of course. So more the number of alkyl groups, lower the stability. And this will be greater stability. So if I have to compare the acidic strength of primary, secondary and tertiary alcohols, tell me, what will be the order? Yes, of course, primary, you can still manage to do the chemistry practical on the chemistry examination day. But what about doing a physics practical and chemistry, physics and bio practical, right? So primary greater than secondary, greater than tertiary. This will be your acidity order. The other thing that I mentioned to you was solvation of the conjugate base. Now, what is this solvation? Definitely, it's got something to do with the solvent, and which in our case is water. Now, let's see our alkoxide ion, which is here, the first one I'm taking up, right? Now, because it's got a negative charge, and we know that our water molecules, so H, OH, positive, positive, negative, because it is burden. So here comes your friend and says, okay, I can help you learn a bit of chemistry. Another friend pitches in and says, okay, I can also help you with the chemistry practicals. You don't need to panic. So what is happening? The solvent molecules are coming in the support of the negative charge on the oxygen and helping it to stabilize. And this is what is called as solvation, where the solvent molecules help to stabilize the ion in the solution. Okay, now come to the second case. Here, the friends want to help, but look at the alkyl groups. They start guarding it, right? And also, don't forget that this is actually a tetrahedral structure. So I have a CH3, I have a CH3, I have a hydrogen, and I have an O negative. So if the friends do want to come and help, you have already closed your doors to it. Yes, they can approach. One of the friends can still come and help you and approach and come closer to help you, but not too many, right? Because now what is happening here is the doors are being guarded by the alkyl groups, and the doors are being mom, dad, everybody's like, no, nobody's helping, he needs to concentrate on his exam, right? So what will happen is that guarding becomes even stronger when you have more alkyl groups. So the solvation, the extent of solvation, so there is least solvation here, whereas there is maximum solvation here. With the result, again we come to the same conclusion that you will be more stable here, and where you are not getting any support, the stability will be the least. In other words, when the alcohol molecule loses a proton, it's forming a conjugate base. Greater the stability of the conjugate base, higher will be the ability of the molecule as an acid. So, we have over here, more the alkyl groups on O negative, greater the instability, more the reactivity, more the basic strength of the conjugate base. So what will be the order of basic strength? That will be 3 degree, greater than 2 degree, greater than 1 degree. What do I mean by basic strength? Ability to take up proton. That's what we said about the Bronsted concept, the ability to take up protons. So more basic, more tendency to take up proton, because this is getting loaded with work. This will be less basic. This will be least basic. So accordingly, the acid corresponding to the primary alcohol, that is CH3CH2OH, will be most acidic, followed by, yes, the secondary and then the tertiary. So if I have to write the order of basic strength of alkoxide ions, I will write it as 3 degree, greater than 2 degree, greater than 1 degree. Now if I have to write the order of acidic strength of alcohols, how am I going to write it as? Yes, well done. 1 degree, 2 degree and 3 degree. Although there are various other factors also which decide the acidic character of, yes, alcohols, which we shall talk about later. I hope this is clear. So let's come back to where we started from. We are talking about the properties or involving the breaking of the OH bond in the case of alcohols, right? And we've already covered the acidic nature, and we said that the order of this breaking up is 1 degree greater than 2 degree greater than 3 degree in the case of alcohol. So primary alcohols more, followed by secondary, followed by tertiary. The next property that we are taking up it is acylation. So let's write down the equations for that one. Okay, so what is acylation? To understand that, first let's break it down and we are going to define what is acyl group for us. CH3, CH2 is alkyl group. RCO group, this is acyl group, specifically actually CH3CO group. And what is acylation? That's the introduction of acyl group in a molecule, right? And that is what is acylation. Now this can be done in different ways. Either we treat the compound with an acid chloride or acid anhydride, or what we are going to do also is esterification, reacting with an acid. So the third category we are going to do a little separately. So let's start. I've got an alcohol. This is being treated with an acid or acyl chloride or acid chloride, right? That's the derivative of an acid in the presence of a base so as to remove the side products. Remember, we are talking about the breaking of the OH bond. Mechanism is not there in our syllabus, so we are not exactly in the syllabus, but at the same time we are not dealing with that level also. And now what I'm going to do is I'm going to flip my molecule. RC double bond O, and to differentiate between the two R's, I'll write it as R dash. And now I'm going to make my favorite box to help me remember the reaction. Now start writing from here. R O C double bond O R dash and HCl. Now because HCl is an acid, you know why we are using pyridine to help drive the reaction in the forward direction, and the product that we've got is an ester. Now you must be wondering why I started writing from here. Why can't I just write RCOOR dash? Think about it. Can I write this product as RCOOR dash? Are the two products same? Are they the same thing? Think about it. Let's expand and see. R, C, double bond O, O, R dash. Look at the products. Yes, they are different. Look at the alkyl groups which are attached. So here we've got the carbonyl group attached to OR dash, whereas here it is OR. So the products on hydrolysis will also be different. That is why in order to avoid mistakes, we start writing from one end and go on to connect the other end. That's where, you know, the tricks of box chemistry actually come in useful. Would you like to write the second reaction, the products of the second reaction yourself? What I'll do is I will again write this molecule in such a way that you are able to write the products yourself. So O, O, C, R, O, C, R and dash. Go ahead and write the products. Make the box. Think again. There we go. R dash COOH. So we need to remove the acid from the reaction mixture. And again start writing from the left hand side. ROOC R dash. Again we form an ester. So what do you have to do? Yes, you have to try and complete these reactions yourself by writing what is required as a condition for the reaction. And to check your answers, you can see the same slides on pen and paper chemistry Google site. If you look for pen and paper chemistry on Google, it will show you the YouTube channel and the site both. So you can check your answers there. Esterification is a special type of acylation reaction wherein what is happening is a carboxylic acid. Earlier we were taking the derivatives of carboxylic acid. The carboxylic acid is reacting with alcohol in the presence of concentrated acid to form an ester which has a fruity odor as well. So again, the logic still applies the same H and OH. Now actually, this doubt crept up in my mind as well, that actually our acids should be releasing H positive and alcohol should be giving us the OH, right? But here if you see, this is H and this is OH, which is quite odd. But we understand the nitty-gritties of this when we see the mechanism of this. But we shall not be dealing with the mechanism in this video. It will become too tiring also, right? Grasping so much of knowledge in one go. But remember, this particular point, this gets confusing many times. So ROH plus HOOCR dash. So what will it form? Write down the product ROCOR dash. You can write it like that, followed by production of water. Now interestingly, this is actually a reversible reaction, because the ester can be hydrolyzed back to the alcohol and the carboxylic acid. That is why this reaction is interesting, and it is called as esterification, especially Fischer esterification. Mentioned in some of the curriculums, not mentioned in some of the textbooks. Just for GK, you can add it to your knowledge. So alcohol combining with carboxylic acid to give us ester and water is esterification. It's a type of acylation reaction only, or acetylation reaction only, but it takes place in the presence of a concentrated acid. What does the concentrated acid do? It absorbs the water to drive the reaction in the forward direction, right? So we have to remove the product, one of the products. If it's a reversible reaction, we always say that you remove one of the products of the reaction in order to drive it in the forward direction. That is why we need the concentrated acid to drive it forward. I hope you could connect to the learning on the channel. If yes, then request you to please help spread this gift of knowledge to more students, more learners, and help them smile. In the next video, we shall be dealing with the properties involving the breaking of the CO bond. And you know what? The order of reactivity actually totally reverses. Yes, we're going to talk about nucleophilic substitution, but alcohols are not so easy to come by. We'll see in the next video. So stay connected, stay happy, stay healthy.